Okay, so there have already been videos on how to prove a rectangle is a rectangle, or how to prove that a rhombus is a rhombus. But what happens if you don't know, like, what your target is? Meaning, you have 4 coordinates and you don't know whether you are proving it's a parallelogram, rectangle, rhombus, or square. Okay, so we are going to do a couple examples. So for this first example, all you know is that we have P is at the order pair of -1 and 4. And again, I like to just draw a picture and having all of my, let me put P here, having all my coordinates with it. So Q is 3 and 6, R is 9 and -3, and S is 5 and -5. Okay? This is where you really need to understand and know all the properties. So what makes a rectangle a rectangle? What makes a rhombus a rhombus? What makes a square, etc. So the where I like to start is make sure that you are labeling the segments. Again, I don't want to see D equals D equals D equals D equals because that's not going to help me follow your work. And I am very specific when I am doing all these steps. So you could start with either showing that it's a parallelogram. You could start with, hey, is this a rectangle? Or you could start with, hey, is this a square or a rhombus? I like to start with the most specific and then go backwards, okay? So I'm going to make like a little chart over here just so I can rule things in and rule things out. Okay, and I like to mess with the diagonals, because if I know the information about the diagonals, I only have 2 segments to deal with, as opposed to having 4 if I'm doing some property with the sides. Because we're dealing with coordinates, obviously any property having to do with angles, we're not dealing with, okay? So I think I'm going to show, or ask myself, are the diagonals congruent? So I need to know if they are congruent, what does that rule in? Or if they aren't congruent, what does that rule out? Okay? So I'm going to use diagonals. So I'm going to use PR, and I'm going to use the distance formula. So PR is -1 minus 9 squared plus 4 minus a -3 squared. Because this should not be new to you, what you might want to do is just pause the video now, try it on your own, and then follow my work and see if we get the same answer. So the square root of -10 squared plus a positive gives me 7 squared. So I get 100 plus 49. So PR is going to equal the square root of 149. I'm going to do now the other diagonal, which is QS. So I have the square root of 5 minus 3 squared plus -5 minus 6 squared gives me 2 squared plus -11 squared. So 4 plus 121. So I get QS to equal the square root of 125. Okay, so the diagonals are not congruent. So I can say diagonals are not congruent. So I'm going to go back up to this list. If diagonals are not congruent, then what does it rule in and rule out? Well, I know that diagonals are congruent in a rectangle. So this can't possibly be a rectangle. I know that diagonals are also congruent in a square. So this cannot possibly be a square. So right now, it could be either a parallelogram or a rhombus. Okay? So, again, I like to go with the most specific, and I'm going to go with a rhombus as far as what makes a rhombus a rhombus. So I am going to, what makes a rhombus would be, again, I like to work with the diagonals. You can see my diagonals here. I know that if this was a rhombus, that these would be perpendicular, meaning that the slopes would be opposite reciprocals. So I'm gonna go ahead and do that. So I'm gonna ask myself, are the diagonals perpendicular? I could have gone another route and just, hey, is this even a parallelogram to begin with? Okay. So actually, I'm going to look back at this again. Yeah, I'm going to keep going with this. So are the diagonals congruent? So I have diagonals. I'm looking at PR, or perpendicular rather, PR. So if I'm looking for perpendicular, that means I'm going to be using the slope formula. So PR, let me get my numbers straight. So 4 minus a negative 3, so the change in y over the change in x. Negative 1 minus 9. I get 7 over negative 10, gives me negative 7 tenths. So PR has a slope of negative 7 tenths. QS, and I gotta get my right hat on here, so we have 6 minus the negative 5, so change in y over, I did 6 minus negative 5, so you do 3 minus 5, gives me 11 plus a positive over negative 2, gives me negative 11 halves. Okay, so because these are not opposite reciprocals, then these are definitely not perpendicular. Okay, definitely not perpendicular. So if the diagonals are not perpendicular, well, and so I got to know when are they perpendicular? Let me go back up here. Well, they're perpendicular in a square, but I've already ruled that out. They are perpendicular in a rhombus, so now I can rule that out. Just because I've ruled all these out does not mean that it's definitely a parallelogram. It could just be a quadrilateral. So I now need to go and find out, is this a parallelogram? So again, I like to deal with the diagonals. So in a parallelogram, I know that diagonals have the same midpoint or bisect each other. So I'm going to look at PR. I'm going to ask myself a question. Do diagonals bisect each other? And what you're actually asking is, do the diagonals share the same midpoint? Or have the same midpoint? So, diagonals, I'm looking at PR. So now I'm changing gears and I'm using the midpoint formula. So I have negative 1 plus 9 divided by 2 and 4 minus 3 divided by 2, which gives me 8 over 2 and 1 over 2. So that gives me 4 and then 1/2, running out of room. So PR has a midpoint of 4, 1/2. Look at QS. So if I do 5 plus 3, I'm going to run out of room, I'm getting smaller here, and negative 5 plus 6 divided by 2, I get 8 divided by 2 and 1/2, which gives me 4, 1/2. So I can say, notice now they have the same midpoint. Okay, so I have shown all the work as to why I have ruled things in and ruled things out. So because they have the same midpoint, I have confirmed that it is in fact a parallelogram. So that is example 1. Notice they take a little bit of time and thought.